Okay, good morning to everyone. We'll start with the same topic what we have started in the previous class, the precision phase shifter. So the main intention of the precision phase shifter is to get a phase shift at the output end, and we have three resistive film R1, R2, and R3 with R1 and R3 is having a length of lambda by 4 plate, and R2 is having the length of lambda by 2 plate. So the center section is called as a rotary type phase shifter, and the whatever signal, if you give the signal EI at the input, you will be getting EI angle 2 times of theta. So it's all because of the rotary section which is in the center, which is having an angle of theta, and that theta is going to get reflected at the output. So that is the phase which is going to be shifted in the phase shifter. So we have seen the components like two resistive films E1 and D3, which is in the rectangular waveguides, and the R2 resistive film, which is of having lambda by 2 plate, which is placed in the circular waveguide. So all these dielectric plates are, so if you take the first and last plate, that is placed at an angle of 45 degree, and it is not having any movements further. It is fixed at an angle of 45 degree, and they are tapered at both the ends, and you can see that why, because to avoid the reflections and all those things. So the center plate is having an angle of theta, and the main thing about this center plate is it can be rotated to 360 degree, and that angle which is going to get generated, or that angle which you are placing the center plate in of, or the lambda by 2 plate, is the one which is going to get the final angle at the output. You can see that EI angle 2 times of theta. So it is completely depending on the value of theta for which we are moving the signal. So the center plate is of length 2L, and the other two plates are of length L, and we can also see that the T10 wave in the rectangular waveguide becomes T11 wave in the circular waveguide. These all things we discussed in the previous class, and further we moved on with the equations and all, and we have also seen that the two components E1 and E2, if you take with respect to the plate, one is parallel to the plate and another is perpendicular to the plate. So when you have those equations to go ahead with, you have written the equations for E1 and E2. So EI cos 45 e to the power of minus j beta L, beta 1 L, and you get E naught e to the power of minus j beta 1 L. So what we have done is EI divided by root 2, we have gone for EI divided by root 2 as E naught. So that is what we have done. So you can see here, so this portion we have replaced by, this is EI divided by root 2. So this portion we have replaced by EI divided by root 2, or it can be written as E naught. So you got E naught e to the power of minus j beta 1 L. So further moving on with the equation E2, also you got E naught e to the power of minus j beta 2 L, and E naught is EI divided by root 2. We have taken EI by root 2 as E naught. So all these things we discussed last class. And further on, we have also the difference phase change. Differential phase change can be written as beta 1 minus beta 2 into L equal to 90 degree. So now we are going to replace this equation with the help of beta 1 minus beta 2 into L is equal to 90 degree. This equation we are going to use in this equations, and we are going to simplify it. So we are going to write the same thing. E1 I have written the same. E1 is equal to E naught e to the power of minus j beta 1 L. E2, here I have written the same, except that what we can do is we can here it is beta 2, So what can be done, instead of beta 2, we can replace it in terms of beta 1. So what I have done here is, so you can see that I have replaced beta 2 as beta 1 L minus 90 degree. So this is what you can see. Beta 2 can be replaced in that form. So beta 2 is replaced as beta 1 L minus 90 degree. So this is what I have done there. We can also substitute instead of beta 2 as beta 1 L minus 90 degree. So 90 degree is pi by 2. So I have written this as E naught e to the power of minus j beta 1 L minus pi by 2. So we can just simplify it further. E to the power of minus j beta 1 L minus pi by 2 is there. So we can write it as e to the power of minus j beta 1 L e to the power of j pi by 2. So this term e to the power of e naught e to the power of minus j beta 1 L is same as E1. So I have this term is same as this term. So I have replaced E1 in place of this. So my equation will be E1 e to the power of j pi by 2. So I got two equations, one in terms of E1. E1 is E naught e to the power of minus j beta 1 L, and E2 I'll get it as E1 e to the power of j pi by 2. So we have both the equations E1 and E2 in terms of B1, beta 1, because beta 2 we have converted in terms of beta 1. So one is having E naught e to the power of minus j beta 1 L. Here it is also in terms of beta 1. So you can either say that E naught e to the power of minus j beta 1 L e to the power of j pi by 2, or E1 e to the power of j pi by 2. This is what you are going to get it. So you write till here, and we'll continue further. So all of you complete the equation still there. So all of you might have completed. Last class only we discussed about these things. You have completed? Is that over?
Yes, sir.
Okay. So further we got two components here, E1 and E2. Similarly, we need to write the equations for, so now you got the components E1 and E2. Similarly, you need to write the equations for E3, E4, and then further, when this is in the circular waveguide, and this is again in the rectangular waveguide, where you will get E5 and E6. So these are the things which you have to further go ahead with. Now you got E1 and E2, and further you need to go with the rest of the terms as well. So it is, once you understand, it is very easy. So the quarter wave section convert. Now what you got, the components E1 and E2 is these two equations you got. So this is the wave which is going to move on further in the circular waveguide. So which has an ability to rotate at an angle of theta, and you also know that here you have written with respect to angle 45 degree, because it was kept at an angle of 45 degree. But here further we are going to write with an angle of theta. So that is the difference, because it is in the circular waveguide. And the length also, if you see here in the previous equation, you have taken it as L. You have taken it as L, because the length of the lambda by 4 plate is L. But when you take the center section, that is circular waveguide, the length is 2 times of L. So you have to take 2L when you write the equation. So those are some of the changes which you can see here when you go for E3 and E4 component. So the quarter wave section convert is linearly polarized T10 mode to T11 mode, and the wave circularly polarized and vice versa. So that's what we have discussed already. The T10 mode is converted to T11 and further to T10 mode. After emerging from the half wave section, the field components parallel and perpendicular to the half wave plates are. So we are going to write the equations for E3 and E4. So first we'll write for E4, E3, and then we'll go with E4. So here the first equation, when you go ahead with, you should use the figure and go for that. So here few things you have to understand. Here in the figure you can see that this is at an angle of 45, this is also at an angle of 45, but when you go with the center section, this is at an angle of 30 theta, and you have the components E1 and E2. Just 1 minute. So we have been discussing on these things. So you can complete that part of it, and then we'll move on to the equations which is there for E3 and E4. So from that, when you write for E3, the equation will be in terms of E1 and E2. So it will be E1 cos theta minus E2 sin theta e to the power of here. What all things you have to be careful is here it is 2 times of L. So 2 times of L you should write. You should not write it as L. It is 2 times of L because of the length of the center plate is 2L. So, and that is one thing. And so you'll be getting E1 cos theta minus E2 sin theta e to the power of minus j beta 1 L. Then we are going to try to simplify it further, and we are going to write it in terms of we'll simplify one by one step and go ahead with that. So substitute E1 and E2. So here instead of substituting E1 and E2, we'll first substitute E2. So let us substitute E2. E2 is E1 e to the power of j pi by 2. So you can substitute E2 here. Substitute this equation here. Substitute the equation E2 in this portion. So what you're going to get E3 is equal to E1 cos theta minus E2 is substituted as E1 e to the power of j pi by 2 sin theta e to the power of minus j 2 beta 1 L. And we also know that e to the power of j pi by 2. What is e to the power of j pi by 2? E to the power of j pi by 2 can also be written in trigonometry as cos of pi by 2 plus j sin pi by 2. It is also same as j. So these things you know, e to the power of j pi by 2 can be rewritten as cos pi by 2 plus j sin pi by 2, and when you write it, it is same as j itself. So e to the power of j pi by 2 can be written as j. All these things are trigonometric relationships which you already studied in mathematics. So all of you can just substitute e to the power of j pi by 2 as j in the equation, and take E1 term outside. So you'll get cos theta E1 in brackets cos theta minus j sin theta e to the power of j minus j 2 beta 1 L. That's what you're going to get. So I'm not too much any difficulty in solving it. It's very simple. Just trigonometric relations we are going to use, and we are going to simplify it further. Cos theta minus j sin theta can also be written in terms of e to the power of minus j theta. So all these things you can just use these things further and try simplifying it again. Okay. So cos, we have replaced cos e to the power of j pi by 2 as cos pi by 2 plus j sin pi by 2. It's same as j. And we are going to replace cos theta minus j sin theta as e to the power of minus j theta. So you got these equations. So you got even e to the power of minus j theta e to the power of minus j 2 beta 1 L is what you're going to get. So what further I'm going to replace here is you can just note down there substituting for E1. You could have done it before also, or later you can do it at this point of time. E1 you have to substitute. So I'm going to substitute E1. What is E1? E1 is E naught e to the power of minus j beta 1 L. So I have substituted E1 as E naught e to the power of minus j beta 1, and rest of the terms are as it is, e to the power of j minus j theta and e to the power of minus j 2 beta 1 L. So let us simplify it. You have e to the power of minus j beta 1 L and e to the power of minus j 2 beta 1 L. So you can write it as e to the power of minus j 3 beta 1 L. So what you are going to get for E3 is E naught e to the power of j theta e to the power of minus j 3 beta 1 L. Similarly, you need to write for the component E4. Now you have written for E3. You got the equation here. With the help of E3, we have written in terms of E1 and E2. Now you need to write E4 in terms of E1 and E2. So you can see all these things in the figure. So E3 we have written in terms of E1 and E2, and E4 you need to write with respect to E1 and E2 in angle theta. So how you are going to go ahead with that? Can anyone of you try with the equation for E4? E4. So E3 is clear for all of you. You can just note down these things. E3 is clear. Any doubt is there?
It's clear, sir.
Okay. So write for E4 as well. And the same method of simplification, substitute E2 and simplify it. Finally, you will get the simplified equation in terms of E naught e to the power of some term you will get. So can anyone try E4? E4. So you have completed this till here.
Yes, sir.
Okay. So let us see how E4 will be. E4 will be also in terms of E1 and E2. We need to write E4 will be E1 sin theta plus E2 cos theta. E to the power of, here you need to use B2. Okay. For E4 it will be B2 and beta 2, and the rest of the things you will get E1 sin theta plus E2 cos theta e to the power of minus j 2 beta 2L. Then let us simplify in the, we have substituted for E2, we have to substitute for E2 here. E2 is E1 e to the power of j pi by 2. Same way what we did for E3. Similarly, you can simplify. So we substituted for E2 as E1 e to the power of j pi by 2. And you have to take E1 outside. So it is cos sin theta plus j cos theta. You can simplify it. It's very easy. When e to the power of j pi by 2 we have already done in the previous for E3. we know that e to the power of j pi by 2 is same as j. So I have replaced as sine theta plus j cos theta. So till here it's very easy. It's very easy to solve. So you can just use the trigonometric relations and keep simplifying it further. So only one step which you have to add here extra is you have to make this beta 2 in terms of beta 1. So as we did before, you have to replace beta 2 as beta 1 L minus pi by 2. So you have to replace beta 2 as beta 1 L minus pi by 2 and then again simplify it further. So j even you have taken it outside, so it is cos theta minus j sin theta. It is e to the power of minus j theta, and you will get you have to replace beta 2 as beta 1 L minus pi by 2. You have to bring all the terms in e1 and beta 1, and when you get in this form, you will get finally j e1 e to the power of minus j theta e to the power of minus j2 beta 1 L e to the power of j pi. So j, you know that it can be rewritten as e to the power of j can be written as e to the power of j pi by 2. So I have replaced j as e to the power of j pi by 2, and you can simplify it. E1 also substitute for E1 as well. Substitute for E1 as well. So substituting for E1 and J, you can write E4 as E naught e to the power of minus J beta 1 L e to the power of minus J theta e to the power of minus J2 beta 1 L e to the power of minus J3 pi by 2. So this term and this term can be written together. So we got E4. E4 will be E naught e to the power of minus j theta e to the power of minus j 3 beta 1 L and e to the power of minus j, sorry, e to the power of j 3 pi by 2. So you can get E3, you can get E4. So you got E1 and E2. From E1 and E2 you got E3 and E4. So I have told you that we have now passed we have completed the circular part of it, that is the resistive film R2 is over. When we pass on, we will get E3 and E4. You can understand that the resistive film R2 is completed and we are left out with the last resistive film R3, which is having a length of lambda by 4. So you have to consider it as L. Okay, you have to consider it as L. So, and it is also at an angle of 45 degree. So you can just write these points. So you can just write these points. After emerging from the halfway section, the field component E3 and E4 may again decompose into T11 mode and parallel and perpendicular to the output quarter wave. At the output end, the quarter wave plate field components are parallel and perpendicular to the quarter wave plate. Now we have to go with the final two equations of E5 and E6. So you can see that this is kept at an angle of theta. So the E3 component and E4 component is with respect to an angle theta. So you can see here this is E5 and E6. So this is the angle theta. So you need to write the equation with respect to that. So you have to write the equation for E5 and E6 with respect to E3 and E4. Let us see how the equations will be uh, for E5 and E6. So when you write E5 in terms of E3 and E4, you are writing in terms of E3 and E4. So it will be E3 cos theta plus E4 sin theta e to the power of minus j beta 1 L. So here it will, so you should be careful in all these things. The center plate, it was 2L, but here it will be L, okay, because the length of the plate is lambda by 4 and it is L. So you'll be getting E5. So you completed these things. All of you have completed or still you are writing it?
Sir.
Completed? No, E4 you have completed.
Yes, sir.
Yes, sir.
Okay, okay. So fine. So once you complete E4, this all these points you can note down, right? What when you write the equation for E5, you have to write it in terms of E3 and E4. So here few things what you have to understand here is the center plate is of 2L. So we have taken in the previous equation as 2L, but here it is in the lambda by 4 length, so it is L. You have to take it as L, and you have to write the equation in terms of E3 and E4. E5 will be E3 cos theta plus E4 sin theta e to the power of minus j beta 1 L. Now you need to simplify it by substituting the components of E3 and E4. So you can substitute E3 and E4. Substitute E3 and E4. And you can simplify it further. So these are all very simple to score, and there is no question twisting of question or unexpected question is not going to come for you. So it's all expected questions which will be having. So you should only think what you have to do is you have to prepare once this all these equations, and you need to draw that figure properly, and write it in the examination properly. Okay, so it's all expected questions what comes for you, and you should not miss marks in all these things which is known to you. And here what we got equation in terms of E3 and E4, and we substituted E3 and E4. So E3 is E naught e to the power of minus j theta e to the power of minus j3 beta 1 L, and E4 is E naught e to the power of minus j theta e to the power of minus j3 beta 1 L e to the power of j3 pi by 2. So you have to simplify it further. So just take E naught term outside, and e to the power of terms also outside. So we'll be getting E naught cos theta plus e to the power of j 3 pi by 2. Why we have taken e to the power of 3 pi by 2 here is you know that it is j. So you have seen here e to the power of e to the power of 3, j pi by 2 can be written as j. So e to the power of j minus j theta e to the power of minus j3 beta 1 L and e to the power of minus j beta 1 L, you can take it outside. These two terms will merge to e to the power of minus j 4 beta 1 L. You can simplify it cos theta minus j sin theta. You will be having here this cos theta minus j sin theta can also be simplified. So it will be e to the power of minus j theta So you have e to the power of minus j theta, e to the power of minus j theta. So you can, that also you can simplify. You can get e naught e to the power of minus e naught e to the power of minus j2 theta e to the power of minus j4 beta 1 L. So if you complete E5, E5, then you can write the equation for E6 and solve it. And you can try what you are going to get for E6. E6 will be E4 cos theta minus E3 sin theta e to the power of minus j beta 2L. So here you need to write beta 2L. Beta 2 you need to convert in terms of beta 1 as well. So all those steps will come extra here. So you can just substitute E3 and E4 and try simplifying it. What you're going to get for E6. So you try solving for E6. So we have substituted for E3 and E4. So you can simplify it further. So what we have taken E naught term outside, e to the power of j theta, e minus j theta, all those terms we have taken outside. Beta 2 we have replaced it as beta 1 L minus pi by 2. And keep simplifying it, you will be getting the same what you got for E5, and E6 will be the same. Okay, E6 will get it as E naught e to the power of minus j2 uh, theta e to the power of minus j4 beta 1 L is what you're going to get it finally. You can solve it out. So all the steps are quite easy to simplify, and we have all this trigonometric relations, and you got the components E5 and E6. So the parallel component is E5 and the perpendicular component is E6. So we'll discuss about that. First you complete and get the equation for E6 as E naught e to the power of minus j2 theta e to the power of minus j4 beta 1 L. So you can just write down these things as well. The E5 is a parallel component E5 and perpendicular component E6 at the output end of the quarter wave plate are equal in magnitude. So you can see that the magnitudes are equal and in phase, and the resultant electric field strength is what you're going to find out. So you just note down these points. One more thing I just want to add to this is you can see here this component E5 and E6. So this E5 is parallel and E6 is perpendicular. You can see the figure, you can see that E5 component is parallel to the plate and E6 component is perpendicular to the plate. So we got E5 and E6 one and the same, and it is E0 e to the power of minus J2 theta e to the power of minus J4 beta 1L is what E5 as well as E6. So once you complete it, we will just move on to the further simplification. The finally what final thing what we have to get is we have to say that it is going to change as per the angle theta. So that is what we are going to do. We have to take the resultant electric field strength. So we will do that next continuation of that. So now if you complete it till here, so all of you have completed.
Yes, sir.
Okay, so you got E5 and E6 and the parallel component and perpendicular component you understood. And now we are going to see the resultant electric field with the help of E5 and E6. So we'll see that. So E out, what is the output it is going to generate will be root of E5 square plus E6 square. So you need to just substitute E5 and E6 here and take the means take the square and take the root of it. So because C5 and D6 is one and the same, you will get root 2 E naught e to the power of minus J2 theta e to the power of minus J4 beta 1 L is what you're going to get. E naught, we have already written it before. We have written for E naught in terms of EI, first time we have written this. Here you have written, here you have written that E naught is equal to EI divided by root 2, or you can write EI is equal to root 2 E naught. So that is the relation what we have written for E naught EI. So that we are going to use it here. So EI can be written as root 2 E naught, or E naught can be written as EI divided by root 2. So finally, you will get E out as this equation. So in place of root 2 E naught, you have substituted as EI. So EI e to the power of minus J 2 theta plus 4 beta 1 L is what you're going to get. So what you can understand from here is output field is depending on the phase change is depending on 2 theta plus 4 beta 1 L. So the frequency component 4 beta 1 L will be always constant, and the variation will be only with respect to theta. So that is what, so this is the explanation what it is written here the same. The polarization of E naught, E out and EI are same except the phase change, that is 2 theta plus 4 beta 1 L. At the given frequency 4 beta 1 L is constant, and the change in phase is achieved by varying the angle theta. So where this angle is varied, this theta is in the center plate. Okay, theta of half wave plate with respect to the quarter wave plate. So half wave plate means R2, with respect to quarter wave plates means R1 and R3. So that is what you can see. So this depends on 2 theta plus 4 beta 1 L, and if I keep the frequency component as constant, then we can say that this 4 beta 1 L remains constant, and this angle theta varies. So finally you can say that the component E out varies with respect to angle theta, the phase component. So the phase of the signal can be varied, and hence this is called as a precision phase shifter. So if you have completed that, next you can write down waveguide T. It is TEE. This T name is put because it looks like a shape of a T. You have three types of T's which you will be studying here. Basically two types, one is called as E-plane T, another is called as H-plane T. So you complete it first, then we'll move on to waveguide T's. So all of you completed. Shall we go on with the waveguide T's?
Right.
Okay. So these are the things which we have studied with respect to precision phase shifter, and precision phase shifter is very important. I am saying it again and again, and you have to just draw that diagram, explain briefly, and then give all these equations for E1, E2, E3, E4, E5, and E6 based on the time and based on your marks. The detailed steps you can give, otherwise you can write the equation and you can write the equation, final equation for E5 and final equation for E6 and all, so that you have to plan according to the time and marks whatever it is available with you, and you have to proceed further. So maximum marks it comes for this precision phase shifter is 8 marks, and or they may go for maximum 10 marks. Okay, so you have to see the marks and you can write it. So one or two steps if you are missing in between to solve those, also not an issue, but the equation, this like these two equations are very important. If you take any of the like if you take E6 means you must write this equation and you must write this equation. If you are very much confident of solving it fast, one or two steps you can complete this, but you should not make mistake in the final answer. Okay, so you can plan according to the time and marks available for you, and you can write it down, but marks will be if you are writing so much detailed steps, if you are missing out one or two steps in between, but the answer you need to have the same. Okay, so you have to do it properly. I'm saying that too much detail, if you are not writing also, it's not going to affect your marks until and unless you are writing the correct answers for final E5, E6 and all those things. So if you don't have time, you can manage. If you have time, please write it properly and write, if it is 10 marks and all, write it properly. So next we are going, all of you have completed that, right? We'll start waveguide is.
Yes, sir.
Okay, waveguide T, as I have told you, the basically it is of two types, and we can say that it is E plane T and H plane T, and the combination of E plane T and H plane T you can get its hybrid T or magic T you call it. So we will be studying here three main T's, and E plane T, H plane T, and magic T or hybrid T. So combination of E and H plane T is called as hybrid T. So here the T, it looks like a T. So the name, it is called as waveguide T. The waveguide T's are three-port components. They are used to connect branch or sections of waveguide in series or parallel. So based on your requirement, you can connect them in series or you can connect them in parallel, and you can have the uh, the transmission of signal either to the two ports, or you can receive the signal from two ports. So as per your requirement, you can use these things as per the application. So basically we have two waveguides, one act as a series or another act as a parallel, and we'll be studying these things in much detail. And somehow one waveguide will be acting as a splitting, or another will be acting as a combining the power in the system. So as I have told you, we have two basic T structures, that is called as E plane T, and another is called as H plane T. So this E plane T is called as a series T, and another is called as parallel. So the basic function of E plane T is it will be in series, and this will be in parallel. So we have this T structure in order to combine the signal, or you have to split the signal. All these things is possible. So we will be just, you can write down waveguide T's, and you can write this explanation. This is very a basic introduction of waveguide T. We'll be studying in much detail. So we have these two T's also. We have some problems to solve, and it's quite interesting. It's just that what you need to know is metrics and metrics properties and all those things. If you know the metrics property, it is very easy to solve these things. So you can just write down these things. We will come back with the same topic in the next class.